Welcome back, everybody. Let's continue our discussion about thermal comfort, focusing in on the climate in which your project might be located. One of the tools that designers can use to visualize and manage thermal comfort is called a psychrometric chart. And there's a couple of different variations on it, one of which is in your textbook. And it is measuring or graphing relative humidity along this bottom axis versus the dry bulb, or remember that's the air temperature on the y-axis here. And so by graphing the human comfort zone of 68 to 80 or 72 to 80, according to this particular textbook, um, on the temperature range right here, okay, and 20 to 80% relative humidity right here, 20 to 80, okay, from here to here, we can find the sweet spot, the human comfort zone. This is the area on the graph where people like to live. All right. Interestingly enough, um, people can be comfortable in colder temperatures as long as you add solar radiation. So add a little bit of sunshine and people can be comfortable even with a colder air temperature. And conversely, with a warmer air temperature, people can still be comfortable if you add some air movement. So a little bit of ventilation, turn on the fan, open the window for a breeze, and people will be comfortable even in a higher temperature area. So that's what these sections on the graph are. All right, your occupants can still be comfortable even in these temperature areas if you add some air movement or some solar radiation. Let's tie in another level of information and see how this particular psychometric chart of the human comfort zone and some different design strategies that can expand the comfort zone. And we can add information for a specific climate. And then it's going to be a different name. It's called a bioclimactic chart. So I've shown you here a bioclimactic chart for the city of San Jose. And this is coming from the Pacific Energy Center's Guide to California Climate Zones, which is included in your module. All right. So on this bioclimactic chart, what they've done is taken the typical range of humidity and temperature and graphed it for every month. So every one of these colored lines is the data for a specific month. All right. And they've just labeled July and December, but in general, you can probably easily tell that the colder months, kind of down here in the winter, you see that the temperature is on the lower end, and the warmer months up here in the summer. And this gives us a graphic or visual view of the climate of a particular city or particular location versus the human comfort zone. And so what can we find out? What do we learn with this information? Well, we can learn the times of year that are comfortable without any particular added heat or air conditioning, excuse me. And we can also learn when we do need to add heat or cooling. All right. And because of the different passive design strategies that are marked on this chart, we can also find out when those strategies are appropriate. So taking a look at San Jose here again, we can see that this area right in here that's in the comfort zone, that is the sweet spot. All right, most of the time in these particular months, we can be comfortable with no conditioning. There is a small amount of the year that is really too warm and can need either ventilation or mechanical cooling. And then there is a much larger part of the year where we're on the cool side, all right? And passive solar heating or mechanical heating is needed to make your occupants comfortable. And finally, there is a piece of our year here that is just too cold for only passive or solar heating, and mechanical heating is needed. Notice that we have a beautiful climate here in San Jose, and there's actually no part of our typical climate data or typical year that you specifically need mechanical cooling or air conditioning. Let's contrast this bioclimactic chart for San Jose with some of the other zones in California and see what we can learn. So again, taking a look at the top left here for zone 4 or San Jose, we have a good deal of our year in the human comfort zone. Probably the majority of the year requiring passive or solar heating, and a little bit sticking out in the mechanical heating and the ventilation areas. Over here in Zone 3, which is Oakland and also San Francisco and some of the coastal areas, you see a much more compact bioclimactic chart with, so there's less variation in temperature and humidity in these areas, all right? But you can see that it is actually cooler also. All right, that's that thermal or sorry, the marine layer effect going on there. We do have some more extreme climates here in California. And so let's take a look at Barstow. This is kind of our southern desert climate. And you can see that although there is definitely a chunk of the year that's in the human comfort zone, um, they have a much wider variation in temperature. And so we have some significantly hot days and also some very cool days. All right. So more need for heating, definitely. And interestingly, you're well within the evaporative cooling zone because they are in a very dry and desert area. All right. Finally, let's take a look at our zone 16, which is kind of our northern California mountain area with the city of Bishop. And we can see that sadly, there really isn't any part of the year that's strictly in the human comfort zone. You want to add passive heating for a great deal of the year. They are very dry for part of the year, and definitely need some mechanical cooling here, excuse me, heating in the winter. All right, so you can see that this bioclimactic chart is a powerful tool for visualizing the different climactic design strategies that you could use as a designer. And also will help you determine when those strategies are appropriate. Thanks, everyone.